fractions can be a tricky concept for many students to grasp. For example, I often get questions like, why can't we just add the numerators and add the denominators? And why do we need to find a common multiple? The activity that I'm about to show you helps students to understand this, and before long, you'll have them adding fractions in next to no time. To do this activity, you'll need 2 clear laminate sheets, whiteboard markers, preferably 2 colours, and also a whiteboard eraser. Now let's just say I wanted to add 1/3 plus 3/5. I'll need to first of all partition one of my laminated sheets into thirds and colour one of them in. Remember, when doing this, a third is just a bit less than a half. So we use this information to find our third and draw a line. And now we just need to break the remaining part into 2 equal parts, like what you can see here. This gives us our thirds. And now I will colour in one of my thirds. Then I need to partition the other one of my laminate sheets into fifths and colour 3 of these in. Remember, for fifths we use our quartering strategy, which is half and then half again. And to find 1/5, well, that is a bit less than a quarter. So we then draw our line down the fifths. And we just need to find our other fifths by breaking up the remaining space into quarters by halving, and then halving each one of these halves again, like what you can see on your screen now. Now that I've got my fifths, I need to colour 3 of these in. The key when doing both of these is to do one of the fractions vertically and one of the fractions horizontally, like what you can see on my screen now. Now, we know that we can't add 1/3 and 3/5 easily because the denominators aren't the same, or that is, these pieces are not the same size. So it's really hard to get a gauge of just how much 1/3 plus 3/5 actually is. So we need to break these up into equal sized pieces. So to overcome this, we can simply lay one sheet on top of the other. Now, as you can see here, my third, that's this space here, has turned into 5/15. And my 3/5, well, that's this space here, has now turned into 9/15. That is, they're the same. 3/5 and 9/15 are equal. But what's more is we can now see that all of the pieces are the same size. And this makes adding these fractions together a whole lot easier, because my 5/15 plus my 9/15 gives me 14/15. And we can make this a little bit clearer by moving some of the overlapping pieces over into these blank spaces here. As you see, giving us the 14/15. Now let's try a subtraction question. Say 2/3 minus 1/4. Therefore, I need to partition one of my laminated sheets into thirds once again. So I'll do that now. Once again, to do it, I need to find halfway and then go a little bit less to mark out my third. Now that I've got my third marked out, I simply need to divide the rest of this space into 2 equal parts. That is, in total, it'll give me roughly 3 equal parts, meaning thirds. And I now need to colour in 2 of these in one colour. I might choose the colour blue in this case. Now for my quarters, I'm going to do that on the other sheet once again. The strategy for quarters is to simply half and then half again. So I'll do that on my sheet now. And now I colour in one of these quarters. I like to use different colours when subtracting as it helps to emphasise the next step. So I'll colour in one of my quarters in red, as you can just see here. Also, once again, remember to do one of the partitions with the lines going vertically, like what you can see, and also with one going horizontally, or it won't work when you lay one of the laminate sheets on top of the other. Now we'll do exactly that. Once again, you can see that my 2/3 has now become 8/12. That is this space here. And my 1/4 has become 3/12. That is this space here. Now the reason I like to use different colours when subtracting is because we can say that the different colours will cancel each other out. Just like +1 and a -1 or a -1 equals 0, a +1/12 and a -1/12 or a -1/12 also equals 0. So let's go through and remove any spaces where there are red and blue on top of each other. Here's one here, another one here, and there we go. And now we can see that there is 1/12 here and 1/12 here that can also cancel each other out. So if I was to move this one over here, it'll go kaboom, and it would disappear, leaving us with a total of 5/12. So there you have it. We've just explored a model for adding and subtracting fractions. Now, whilst I love this model and use it all the time with my students, I always encourage teachers to also reflect on it and ask themselves the following questions. That is, what advantages does the model have over teaching fractions using an algorithm or a more traditional approach? The second question is, what limitations might this model have? And how would you overcome these with your students? The third question is, could this model also be used for multiplication and division of fractions? That is, could you use it to teach multiplication and division of fractions? And the last question is, if it could be used, how might you use the model to teach these? So there you go. We've just explored a fantastic model for adding and subtracting fractions. My name's Tom Moore, and I'll see you next time.